In this video we'll show you how we can draw up the part which is shown here in this PDF file and then create the machining program for it. Okay, so I'm in the CAD system now, so I'll just minimize that. So the first thing I'm going to do is draw a couple of lines. So I go into line, angled line, that draws a line across the screen at the current angle. I just need to snap the line onto that center position there. So I do that using near snap. So that's now snapping that line to the datum. That's click and draws that line. Now I change the properties of the line to 90 degrees and draw another one there. Okay, so now I can just draw some lines parallel to that. So I'll draw a line parallel to this one, which is 62 to the left, and I'll draw a line parallel to that, which is 7mm below. Just zoom in on that a wee bit. Okay, so I need another line parallel to this one, which is 1.5 above, which is the base of the slots. And now I need just to draw the center line of the slots here, so I use the parallel line option again, and that's going to be 4.75 to the left. So that's the distance between each slot. So that's 2, 3 and 4, and now I do the same thing over here, but this time I'm going right first, second, third and fourth. Okay, so where these lines intersect, I need to strike two lines which are the same as the tool. So if we're using a 90-degree tool, so it's going to be 45 degrees. So I stay in line mode, angled line, and the properties of that are 45 degrees. Now if I change my snap mode to intersect, it will find the intersect between these lines. So this will look a little bit untidy to start with, just whilst all these lines are drawn. And now I do the other set of lines at 45 degrees, so that's the back end there. Okay, so let's just zoom in so we can see a bit clearer there. So what I need to do now is use the intersect command with split items, which will break items apart, and I'll use the area facility. So if I click and drag around an area, everything within that area has now been broken apart, and I can simply use the delete option here just to delete out the things that I no longer require. So it's fairly straightforward just to go through and delete out these bits that are not needed. And as I do that, things are becoming clearer as to the parts that I want to keep, and the shape is being revealed. Okay. Right, so now I do the same thing over here. Intersect with split within that area, then use the delete button just to delete out the bits that we don't want. Okay, so it's very straightforward and a simple task, just deleting the bits that we no longer want. There is a way of creating this as a feature and then copying it across, but by the time you've done that, it's sometimes just easier just to do things as they are. So we'll use the split option and just split those two items there. Okay, so now I can create the profile. So we go into CNC and I want NC profile. So this is the start position. I can leave all of those options as they are and just indicate the end position. So this blue tracer line gets as far around as that, and then I just need to finish that off. Okay, so that's created that profile, which is what we need to take into the CAM system. That's the equivalent of a polyline. So if we save that away, and I'll call it shaft 2. So now we can go into the machining software. So that's the shape. The first thing is the setup. So this is where we can set up the tool change position. So this is where the machine will start and where it will end. If we want to enhance that graphic, we can right click the mouse in the drawing area and say enhance profiles, and it just draws some lines between the top and bottom. So now we can define a tool, and it's going to be a turning tool. It's going to have an included angle of 90 degrees, and it's going to have the primary angle, which is measured from the 3 o'clock position right round to the end angle there. So if that's 90 degrees tool, which is 45, becomes 225. So that's the tool tip. If we set the tool radius, the tip radius to whatever we want it to be, normally 0.8 or 0.4, and to get the tip so that it's sitting exactly on the center line, we change the Z offset to 0. So that now means that the tool tip is exactly on the center line of the datum position of the tool is on the center line of the tip. Okay, so now we can select that tool for use, set the spindle speed, and the feed rate can either be expressed as feed per minute or as feed per rev. Okay, so that's set up the tool. So now we can do a turning operation. So this will machine anything it finds within a rectangle. So to set up the cycle limits, I can set the bottom right hand corner of the rectangle and the top left hand corner of the rectangle. So if I want to, I can also just type in the values here if I know them. So let's say we're going to start at 8 millimeters. We'll set the cut depth to 1 millimeter and the retract distance to say 2. Okay, so that roughs out that area and machines into the groove, but it doesn't get right into the bottom of the groove. So if we animate the tool and run it, this is the tool tip here. Now if we decrease the cut depth on that, we could get that to machine right into the groove, but it might be that we want to do a roughing pass and a finishing pass. So if that's the roughing, then we do the finishing using the profile turn operation, and we'll have a normal approach. So we'll get it to start cutting down this chamfer. So we'll start over here maybe with a parallel approach of 2 millimeters, and then when it runs off the end here, we'll get it to do a normal runoff with 2 millimeters as well. So it will try to machine the whole of the profile, but we only want it to machine certain parts. So if we go into the options tab, we can use the partial machining. The system will automatically number each one of those elements as a span. So span number 1 will be here, but if we wanted to start at span number 2, we just click that, and then here span 29 is the end part. If we don't want to machine that, we just take it back to 28, which is this one here. Okay, so now we can use the go to command just to bring the tool away from there at rapid. So that just retracts the tool so that it's now safe, and now we'll send the tool back to its home position using the go to command, send tool to home position. Okay, so that's created that machining program. Now we can create the G codes. So if we go back into centerline mode, choose the post processor, and we'll use Mach 3 vector. So that will run through the program again, and that opens up another window at the bottom here, and that is the G codes to run that part.